Welcome to the unit Water Plus, a Level 4 Master of Landscape Architecture studio at CEPT University. This unit was taught by me, Chandrani Chakrabarti, with Riya Shah as the teaching associate. A combination of increased urbanization, climate change, and reactive infrastructure planning are rapidly depleting our water supply in cities across the country. The crux of the studio is to focus on urban water issues. For this, the studio explored nature-based solutions around these degraded urban water sites of varying capacity and wetness as potential catalysts to generate social spaces. When faced with urban pressure, various water-holding sites, be it streams, water bodies, lakes, or porous vacant lands, scrublands, all go through the vicious cycle of negligence, degradation, and slowly becomes an eyesore. Perils of urban water actually goes beyond the surface into the unseen realm of reduced recharge and soil contamination affecting the groundwater. Keeping water positivity and climate resilience as a focus, the unit worked around the Caricut Canal in Ahmedabad. Students constructed multidimensional problems and then crafted adapted solutions around the disturbed water sites that can be tested across time and adverse scenarios. This is the aerial shot of the site with the Caricut Canal highlighted in blue. Although the studio explored the entire stretch of the canal, the final sites were limited along and adjacent to the southern stretch, from the Odhav GIDC area to the Chandola Lake. Let's go on a quick tour through the site starting from the Chandola Lake. In a quest to find a solution for this complex site, where the pollution from surrounding industries was always omnipresent, the studio investigation hinged on these questions. How can we change the perception of water in the city? With the growing water crisis, how can the new designs thrive for becoming water positive? Can there be a reimagination of positive community engagement with water? And can there be resilient water solutions which will make the cities more climate adaptive? This is the overall process across 3 modules. Loosely, as one moved from absorb to reflect to dissipate, the design transformed across scales from L to M to S respectively. Each module were designed with expert lectures, workshops, and reviews, which are marked in red dots. Since water was the focus, a qualitative and quantitative analysis of water was done in each module. Let's start with the first module, Absorb, which was for 5 weeks. At this initial stage of the studio, students framed their first impression from the site visit, followed by the documentation and interviews of people residing across the site. This was aided by a workshop on how to work with communities by Nikhil Dhar. Then the natural layers of the site like topography, hydrology, soil, vegetation, groundwater prospect, along with the landmarks, roads, land uses for both current and future development were extracted using GIS, aided by a workshop with Tapan Modi. And water calculation was done at a larger scale to understand the pattern of stream corridor with respect to the land uses. This was aided by water workshop with Park Mehta. Module 1 ended with vision plan and strategies resulting from the synthesis of natural layers, community and environmental issues on site. Students worked in groups to have 5 vision plans across the studio. From the multiple site visits and vision plans, these typologies of studio sites were identified. The 10 students chose from these according to their interest to create nature-based solutions that will make the cities more resilient to growing climate challenge and can double up as social spaces. Module 2 is Reflect, and it spanned for 4 weeks. This module started by a SWOT analysis to decide on a particular site from similar typology. For example, here the student was interested in remediating the site with industrial waste and followed a comparative analysis of 3 such sites that will be converted to future industry, residential, and an urban park before deciding on the final site. Followed by a program development on the chosen site. A detailed water calculation was further done at the site level. The type of quantitative analysis varied greatly. For example, this particular project calculated the designed capacities of retention and detention on site to keep an existing stream corridor through a neighborhood park. Or in this case, calculations were made to create a balance between the canal working as a conduit with intermittent urban sponges to allow groundwater recharge. This particular project addressed the community water issues by calculating the needs at 3 different scales, from individual to a cluster and a neighborhood. While this one followed a qualitative rather than quantitative method to create a guideline for sponge neighborhood depending on the stream corridor and the scale of the open spaces available. The water calculation and the site analysis ended in crafting a master plan. This was the intervention at the L scale. that would respond to the strategies set out in the vision. Module 3 is Dissipate for a duration of 7 weeks. It was about testing the site and started with the changes in character of master plan in summer and monsoon. Like this project shows that almost all sinks holding water are active in monsoon, whereas in summer only the grey water treatment pockets and downstream sinks are active. And the northern part of the site has a dry stream corridor in summer. The designed calculation of water retained on site also accounted for the infiltration and evaporative losses during summertime. Depending on the design of the master plan, a smaller area was identified that showed maximum flux between the seasons. This became the S-scale site, where the experiential quality of the site was demonstrated through sections and potential ground wetness was mapped to respond to the planting density and grain plan with different planting zones. The chosen S-scale plan was further explored for its resiliency across seasons and extreme scenarios. Site resiliency was tested in multiple ways. In this instance, the student looked at the site transformation from a drought condition through 5, 10, 15, 20 and 25 mm of rainfall intensity. Whereas here, the student used the seasonal flux to show how practices and professions in a community can adapt to differential water on site. And this one looked at the morphing condition of the naturalized canal bed and the subsequent changes in planting and program with respect to seasonality and extremity like flood and drought. The planting density on the S-scale plan was also done on a hard model to understand the scale and the experiential quality of the site. Finally, the students tried to tie back the S-scale design to the larger context of vision and beyond. This is a snapshot of the resolution of the design across the 3 scales from 3 different projects in Monsoon 2023. This is the same representation of the projects across scales in the Monsoon 2022. And this is for Monsoon 2021. On behalf of the Water Plus Studio, Riya and I, along with all the students, Apratim, Bhairavi, Deepak, Ishpreet, Rutuja, Sejal, Simran, Sneha, Vandana, and Vishal, we thank you for your time. You can visit the portfolio website to look further into individual students' work. Thank you.